Hi guys. Next chapter that we're going to do is the binomial uh, expansion, which we've actually looked at before in the year one maths, but there's a few other bits and bobs going on in year two. It's quite a nice topic, follows on pretty nicely, so let's get going. So, we're going to start off by just thinking back about our binomial coefficients. Um, So you might remember we have n choose r, which gives us the binomial coefficients in any expansion that we do, a plus b to the power of n. Okay, so this actually n choose 0, n choose 1, n choose 2, the coefficients going up. The powers of a are descending and the powers of b are ascending throughout this expansion. And n, quite importantly, has to be a natural number. So for example, we have to expand something like this, 1 plus 3x to the power of 3. So let's quickly run through this. You might remember how to do it. Maybe you want to pause the video here and have a quick bash at doing it yourselves to see if you can remember. So I'm going to expand this. This is quite a nice expansion because you'll notice that the a in this is actually 1. So if the a is 1, we can just ignore all of the a's throughout this, because 1 to the power of anything is always going to be 1. So this actually makes this into quite a nice easy expansion. So the first term would be 1 to the power of 3, which would just be 1. And then we work through the rest of our expansion. So we have n choose 1, which is going to be 3 choose 1, b, which is 3x. So I always tell you to put it in brackets. 3 choose 2, 3x squared, and then 3 choose 3, 3x cubed. You don't need to write 3 choose 3 because you should know that's just 1. Okay, and you can see it's the final term in here is always b to the power of n. So if we work out what these are, I mean 1 is just 1. 3 choose 1. Hopefully, you might be able to just remember these for your from how to work it out, or you could use the formula. Just a quick reminder of how you do this in your calculator. If I do 3 and then shift NCR, so remember another way of writing this binomial would be this binomial coefficient here would be NCR instead of NR in the kind of vectory brackets. So 3 choose 1 is 3, so this is going to be 3 times 3x, which is 9x, and then here we're going to have 3 choose 2, so 3 choose 2, which is 3 as well. 3 times by 3x squared, which is 9x squared, 3x in brackets squared. So that's going to be 27x squared. And then 3 choose 3 is just 1. So remember, we're saying how many ways are there of choosing 3 things from 3? There's only one way, and that's to choose all 3 of them. So this is also going to be 27x cubed, like this. So that's the expansion of this here. Okay, that's quite a nice simple thing to do. Now we want to ask ourselves a different sort of question. So the question I want to ask is, well, what is going to happen if I have a expansion like this that I want to do? Like, what if I wanted to expand, say for example, 1 plus 3x to the power of minus 2? That would be a bit of an issue if I wanted to do this, because in this case what happens is the n here in this formula actually becomes minus 2. And let's say that I wanted to do for my first term minus 2 choose 1. Well, we're going to encounter some problems here if we do this on our calculator, because minus 2 choose 1 Your calculator doesn't know how to do it. And we kind of know as well, in this expansion, we keep going until r is the same as n, and then that's just going to be the last term, because there's a finite number of possible terms. But there's going to be a bit more of an issue here, because if we did -2 choose 1, -2 choose 2, -2 choose 3, and then we carried on going, it would go forever. And that's another interesting problem that we have. But we're going to have a bit of a think here. So what I want to think about is, what is n choose 1? Okay, so what I'm going to do is I'm going to say, well, here we're just going to be looking at our kind of binomial coefficients in terms of n. So let's just think about, let's forget about that other bit for the minute, and we'll just think about binomial coefficients. So you might remember that there's a quite nice way of working these things out, which is that if I have n choose 1, so I can do this in this formula here, that's going to be n factorial over 1 factorial times by n minus 1 factorial, like this. Okay, 1 factorial is obviously 1, n factorial is n times by n minus 1 times by n minus 2, blah blah blah, until we get down to 1, and n minus 1 factorial is n minus 1 times by n minus 2, and so on, again, until we get down to 1. What happens is, well, this is just a nice fraction with some common factors in the numerator and the denominator, and the answer is n. So actually, if I wanted to do, although my calculator doesn't know how to do a factorial with a -2, if I wanted to work out, and in fact it's not possible to do a factorial of -2, if I wanted to work out what n choose 1 was and n was -2, I can actually just use this formula. So I can use a bit of algebraic manipulation, and actually n choose 1, well, if n was -2, it would just be -2, which makes sense, because we should know, actually, if we do n choose 1, it will always just be n. We should just remember that, I think, really, from year 1. So let's have a look here now at n choose 2. So if I'm doing n choose 2 here, I can do the same thing again. So I could say, well, n choose 2 will be n factorial over 2 factorial times by n minus 2 factorial. Right out the top and the bottom, so n times by n minus 1 times by n minus 2, and so on, down to 1. 2 times 1 for the 2 factorial, I'll put that in brackets, and then the n minus 2 factorial would be n minus 2 times by n minus 3 times by, and so on. And again, we get a bit of cancellation happening. So the n in the top has no common factor to cancel with. The n minus 1 in the numerator has no common factor in the denominator to cancel with, but the n minus 2 does, and actually there will be an n minus 3 here that cancels with the n minus 3 as well, but I just didn't write that. So there's going to be an n minus 3 there that cancels with this one. So actually, a formula for n choose 2 is n minus 1 over 2. So I can again use this if n is a negative number or even a fraction or something like that, because your calculator also won't be able to work this out if it's a fraction. I can use this to work out what -2 choose 2 would be. Okay, so e.g. -2 choose 2 would be -2 times by -2 minus 1 over 2. So -2 minus 1 is -3, -2 times -3 is 6, 6 divided by 2 is 3, and that would be the answer. Okay, so quite a interesting piece of algebra here to manipulate this, and indeed we could actually do the same exact thing with n choose 3, I could write out all the terms, cancel them, and I would get a similar formula for n choose 3. So I'm just going to write that out here. It would be this. So I could also, I mean, I've written this out with some time. I see why I've written it out like this in a minute. I think this makes it a little bit easier to kind of, I think, remember what it would be, because you could immediately look at this and say, well, if it was n choose 4, I'd do n minus 1, n minus 2, n minus 3, 4 times 3 times 2 times 1 in the denominator. Okay, and some people would actually just write 3 factorial in here. I've written it like this because this is how it turns up in the Excel formula book. So if I did actually have a negative n, or a fractional n, in fact, this would work for as well. Although I can't use my calculator to work out the binomial coefficients, I can just use a bit of algebraic manipulation in these formulas to work out what it is. So I can just substitute whatever my value of n is in here and then go. We do still have the issue that it would go on forever, because our increasing value of r would never end up being the same as the n value. So that's a problem. It's not really a problem. And also, I'm going to point out that I have done this specifically with an example where the value here is 1, because that ignores the a. Okay, we have to ignore the a here to keep this tidy. So I'm going to just skip over before I end up rambling on for a bit too long. What we can actually do is we can reduce this to a new formula for a binomial expansion, which is this one. So if in this case n is, like for the original binomial series, if n is a non-natural number, because this first formula only works for natural numbers, and a is 1, then we can use this version of the binomial expansion. And you'll notice there's actually an extra little bit here where it says the modulus of x, the magnitude of x, has to be less than 1. And I'm going to talk about that in a minute. Okay, but this is for if n is any real number, so your power outside the bracket could be a negative or it could be a fraction. This is an expansion that will work. Okay, but we have to have a being 1 so that we can reduce our binomial coefficients to the formula that I've just shown you. Okay, and it is an infinite series in this case. So e.g., find the first 4 terms of 1 over 1 plus x, or do a binomial expansion and find the first 4 terms. So you quite often will get questions like this, where it's not obviously written as a bracket. I mean, I'm just going to take it and say 1 plus x to the power of minus 1. Okay, the first thing, if it says to find first 4 terms or do a binomial expansion, is to actually write it as a binomial, i.e. a bracket with 2 things inside and a power. So here we actually have, if we compare this, 1 plus x in the bracket, so that's all fine and dandy, and we have n, which is minus 1. So we're just going to use this formula for the first 4 terms where n is minus 1. So the first term is 1, the second term is nx, so n is minus 1, and then x is just x. The next one will be minus 1, minus 1, minus 1 over 1 times 2, multiplied by x squared. And then the next term, so we have to do a little bit of a jump here and think about what the next term would be. It would be minus 1 times by minus 1 minus 1 times by minus 1 minus 2 over 1 times 2 times 3. So this is actually the n choose 3 that I worked out in the previous page, and then x cubed, like this. And then dot dot dot, because it goes on forever. As I just said, we never get to a point where n and r are the same. So this is an infinite expansion. And then we just have to simplify it, and we get the answer. So 1 minus x, and then what will this be? I think it would just simplify to plus x squared, and then minus x cubed plus dot dot dot. And that's the first 4 terms of this expansion. you might want to think to yourself, why do I care about this? I mean, there's a few reasons we might care about it. If we wanted to make an estimate or some kind of statement about 1 over 1 plus x, it might be easier in some cases to do some algebra on this instead of this, or like substitute numbers into it, perhaps. Or maybe if I wanted to do a differential or an integral, I didn't care about the exact result, I just wanted a good estimate for small values of x, i.e. less than 1, then I could actually use this version instead, because it would give me a good estimate of what's going on, at least for these values, for 1 over 1 plus x. Okay, so quite simple, really. Some of the ideas behind it a bit complicated, working out why those things are there, but really the maths you have to do is pretty straightforward. So I'm going to jump straight into a bit more of a tricky exam question here. So this binomial expansion. So you'll notice again, there's actually something next to this, which is what values of x is it valid for. Here it says, because it has 8x in the brackets, the modulus of x has to be less than 1 over 8. I'm going to talk about why that is in a minute. You might want to have a little think about it before we get on to that discussion. I am going to go ahead and just start doing this. So this is 1 minus 8x to the power of a half. First thing we always want to do, write it as a binomial. It says expand up to and including the x cubed term, simplifying each term. We can use this. This is in the formula book, so we're going to always have this available to us. This formula for the binomial expansion. So we just start filling in our values from here. This is really just an exercise in being neat and doing all your algebra properly. So 1 is the first term, as it always is. I mean, at least in this case, where we have 1 as a first term in the bracket, this is always going to be 1. N is a half, so I'm going to put a half in brackets. And then the important thing that we have to be really careful about, and this is similar to the year 1 binomial expansion, is that here we have minus 8x. That is the x from the formula. Okay, so in this formula, everywhere where it says x, we're going to put in minus 8x. And we're going to do that in brackets, because then when we tidy it up later, it's going to be easy to sort out all the negatives. Okay, always put things you substitute in brackets in this. So like this one would become a half minus 1 over 1 times 2, and then minus 8x squared. And then the next term, a half minus 1, half minus 2, 1 times 2 times 3, minus 8x cubed. And then we have to put plus dot dot dot, because it says this is, we want to finish at x cubed, but it does keep going on forever and ever and ever after that. It's an infinite series. 1 half times minus 8 minus 4x. We can work out this bit. This is a half times by minus a half, which is minus a quarter, divided by 2, which is minus an eighth, times by minus 8x squared, minus an eighth times by 8 squared would be 8 again. And this minus becomes positive, so it's just going to be 8x squared. You can do all this in your calculator. I just like doing a bit of mental arithmetic every now and then. A half minus 1. Oops. Multiplied by a half minus 2. Nearly there. Divided by, we'll just put 6 in because we know that's 6. There we go. 1 over 16. Multiplied by minus 8 cubed. I'm just going to times it by 8 cubed and then remember it's a minus. There we go. 32. So it's minus 32 x cubed plus dot dot dot. You can often get big old nasty fractions in these answers here. Just check that's correct. Here, that should be negative apparently. Oh, of course it should. There we go. Alright. that's that. So what's the deal with the validity? So I spoke a bit about this part that I highlighted here. Modulus of x is less than 1. So here's that expansion written out again. I'm going to think what happens to this expansion as the value of x changes. So we know that we've been told in this question the limitation is that the size of x has to be less than 1. So the modulus of x less than 1 means that x is essentially bigger than minus 1 and less than 1 because the total size of it has to be less than 1. So here we're going to think about what happens to the expansion as the value of x changes. So if I pick, let's say, let's just pick a number which is bigger than 1. So if we say x is greater than 1, e.g., let's put x equals 3, what happens? So what happens if x equals 3? So this would give us 1 plus 3 to the minus 1. So we could obviously work this out. This would be a quarter. But we're looking at what happens with our expansion. So it would be 1 minus 3 plus 3 squared minus 3 cubed plus 3 to the power of 4 and so on is what would happen in this expansion. Have a think about this on the right hand side here. It's obviously not going to be the same as a quarter. And what's actually happening is we've got 1 minus 3 is minus 2 plus 3 squared is going to be 7 minus 27 is minus 20 plus 3 to the power of 4 would be 61. And what's happening at every stage of this is getting wildly bigger and going away from any particular value. So every single term here is bigger than the previous term. And what's going to happen is that this is going to be divergent, what we call divergent. So it's not going to converge towards a certain value. So it's going to spiral off towards infinity and give us no kind of meaningful answer. If I pick a number x is less than 1, so e.g. let's just say x is a half, nice obvious one like that. So we have 1 plus a half to the minus 1, which again we can obviously really easily work this out, but we want to know what happens in our expansion, like how accurate is that. So 1 minus a half plus a quarter minus an eighth. I'm just putting my values into this at this point. Now we can see what's happening here. The next one would be plus a 16th and then minus, sorry, and so on. So in this case, because the value of x is less than 1 and we're doing x to the power of something, that x to the power of something is getting smaller with every single term. So actually, as we tend towards infinity, this term, each of these terms, is smaller than the previous term. So what's actually happening here is that it's converging. Okay, so in the first case we have divergent and here we have convergent. So in the first case it's diverging away off to infinity. In the second case it's going towards a certain value because each thing I add is smaller than the previous one. So eventually this is just going to kind of, for all intents and purposes, stop getting larger and kind of be almost equal to a certain value. I should say actually this is when x is between 0 and 1. We can also do the same thing. What happens if x is in between 0 and minus 1? So we would just put x equals minus a half. So our expansion in this case is going to be 1, then it would be the same thing, but with the sign swapped. Okay, so we're going to end up with this same stuff going on. Alright, so here it would be 1 and then minus x would be plus a half, plus x squared would be, well, it would be plus a quarter, plus an eighth, plus a 16th, and so on. It is convergent again. Okay, so we are going to end up with another convergence sequence because it's getting smaller every single time. So we can here see if x is between -1 and 1, we end up with a convergent sequence, and this is a valid expansion that will give us something roughly equal to what we started with. In this case, when x is greater than 1, it is not. And it's easy to see that it would be the same thing going on for any value of x greater than 1, because every power will be bigger than the previous power. Little interesting aside, what happens if x is equal to 1? Well, we get 1, -1, +1, -1, +1, -1, +1. What is the value of this? Is it if we stop here? So let's say I stopped at this point. 1 minus 1 is 0, then I add 1, I get 1, 0, 1, 0, 1, 0. So the answer to this just keeps flitting between 0 and 1. And actually, this is equal to a half, because we can kind of think of it, although this isn't exactly correct, like taking the average of 0 and 1. It's always going to be either 0 or 1, so we say, oh, it's a half. There's lots of ways of proving that this is actually a half, but not in A-level maths. So for the purposes of A-level, x equals 1 is also not valid in a binomial expansion. So therefore, we say the limitation of x is that x has to be between 1 and -1 for any of this to work. Similar thing. What about this one? So this is the other one we did. Well, in this case, we say that this whole thing, -8x, has to be between -1 and 1. Okay? And this is where the modulus sign becomes quite useful, because instead of saying x has to be bigger than -1 or less than 1, we just say, well, modulus x is less than 1, like this, and or magnitude of x is less than 1, I guess is a better way of saying that. So here, well, I've got a similar thing going on, which is that the whole of that -8x, because remember that's what we substituted in, has to be less than 1. And because this is a magnitude, we can just ignore the negative. So 8x has to be less than 1. So therefore x, the magnitude of x, has to be less than an eighth. Because we can divide through the 8 here, because it's just a constant value. So that's the validity for the first one. And if they asked you for the validity, that's what you would say. The magnitude of x has to be less than an eighth. So, quick answer. The validity of an expansion 1 plus ax to the power of n is valid if, well, you can write it in one of two ways. You can write it that x has to be in between -1 over a and 1 over a, or another way of writing the same thing, the modulus of x is less than 1 over a, and that's how you often see it written in exam questions. This is exercise 4a. Pay particular attention to question. There's a few tricky questions in here that I didn't want to necessarily go through in this video because I want you to have a go at them yourselves. But particular attention to question. So where we are, page 92. Yeah, 7, 8. So basically the exam questions. Alright. So questions 7 and 8. But I think I say question 7 in particular, I might actually go through that as like an example at the beginning of the next video. Okay, so this video's gone a bit long, I think. So let's stop it there, and you can go and have a go at that exercise. Alright, bye bye.